So hello and welcome to the Refreshing Views Observatory. Tonight we're going to look at the peaks of eternal light right down at the southern pole of the moon, and we're going to turn this raw camera feed live from the telescope into a high resolution image. So we've actually got several interesting things happening in this field of view. The first is that yesterday a lunar lander called Odysseus actually landed on this part of the moon, so we're going to go and try and pick out its landing site. Unfortunately, I don't think this telescope can pick out the lander itself. I think we probably need to be in lunar orbit. So we'll go and find the landing site. Now the reason, what makes this field of view so interesting, the reason why it's actually landing here is that the mountains are so tall and so close to the southern pole, the peaks are always illuminated by sunlight. That's why it's called the peaks of eternal light. And conversely, the crater floors, they're always covered in shadow. So if you have a crater floor that's never been illuminated by the sun, it's going to contain frozen water from all the cometary impacts over the millions of years that form these craters. And they believe that there's going to be frozen water down at the South Pole, buried in the soil from all these impacts. It simply hasn't been boiled away by the sun. Now, if you want to build a lunar base here, a manned lunar base here, like NASA's doing the Artemis program sometime in the next decade or so, so you've got a source of water and you've got a source of solar panel. And I think it's the third Artemis mission, Artemis 3, is actually looking at putting a lander, a manned mission, to this part of the moon. So this is a telescope we're going to use tonight. This is my Celestron C11. We've got the Player 1 camera in here. I've also got a ×2 Barlow, so I'm shooting at f20, and that's sitting on top of the AZ-EQ6, so we're tracking equatorially. So in addition to the telescope itself, we're going to use 3 bits of freeware. They are FireCapture, and FireCapture controls the camera. That's what we're going to use to capture the video. The second is AutoStakkert 4. Now that's what's going to sort out all those frames, all those video frames that we capture using the camera. It's going to sort them out into quality order, and then we're going to stack the good ones and reject all the blurry ones. And the final one is Registax 6. That's what we're going to use to do our sharpening process. That's what we're going to use to bring out all those hidden details, all that data, all that information that's hidden in the data. So I've also sorted the video out into chapters from the introduction all the way through to the video capture, the image capture, the sorting, the stacking, the sharpening, and then that final processing in Photoshop. So just hunt through to whichever parts you want. And if you want to see this in more detail, the complete end-to-end process, I put a video together that goes right the way from the equipment setup, choosing a camera, through to that final processing. So check out that video if you want to see a more detailed view all the way from start to finish, from that lunar capture to processing to presenting a final high-resolution image. You can actually see those mountains there. So what I'm doing now is just capturing with the video camera, with a high-speed astronomy camera. I'm capturing, what is it? Well, I've got the video camera on, I'm recording the screen, so it's actually about 20 frames a second. If I wasn't recording the screen, it's normally about 45 or 50, so I've gone for 3000 by 2000 pixels. So my poor hard drive is really filling up with data. So what we'll do is we'll record loads of video of these mountains and the surrounding area. We'll then use the software, we'll sort through those, we'll reject those that are blurred by the atmosphere, we'll keep the sharp ones and stack those one on top of the other, and that reduces the noise, gives us loads of data that we can then sharpen and bring out all these fine details. So I've actually had a lovely message from Mike. Mike messaged me the other day to say that his young son Harry didn't want to have a bedtime story. He wanted to be able to watch videos, Refreshing Views videos of us exploring space. So Harry's actually, where have I put it? Here it is. So Harry's put this picture together, he's sent it in, his picture of space. And Harry, I hope that you're one of the lucky European astronauts who get to travel to the moon and work at the lunar base. So good morning, we're back again in the observatory. I'm feeling a little bit more refreshed now, having stayed up late observing the moon. So on the screen we've got the 2 video captures we recorded, but I've recorded several more, but these are the 2 we're going to process today. And what we're going to do is we're going to put them through a program that sorts them into how sharp they are. We'll then reject the ones that are blurry, we'll keep the sharp ones, we'll stack those, and then we're going to sharpen them and bring out all these hidden details. It's all there in the data, it's all there in the signal, but what we're going to do is reject the rubbish ones and just keep the good ones. So let's have a look at each video in turn. Now I record in SER format, And again, if you go back to the tutorial, you'll see that I set FireCapture so that it's recording in universal time. And I also use the WinGPOS file naming convention. If you go to the original video in settings, you can set it so it's always recording in universal time using the WinGPOS format. So that means that wherever I am in the world, whatever the time zone is, whatever the daylight saving time is, it's always using the same time convention. So I've got the year 2024, February 23rd at 22:07 and 3/10 of a minute. So let's open that one up. Here it comes. So this is the left hand side of the southern polar region, and I've got the crater Moretus here, and you can see the mountains. How cool is that, those mountains down there? And I think, if I remember rightly, the South Pole is somewhere around in there, I think. So that's the first video file. Let's reduce you and open the second one. And there's Moretus again. So we've got a little bit of file. What we'll do, we'll mosaic these together so the images line up. And again, you've got those mountains there, those two big peaks. Large crater there, the floor is completely full of shadow. It's quite pretty, isn't it? And then a big crater just here on the limb. Right, let's close that down. And we're going to open up AutoStakkert 4. So in my original video we did AutoStakkert 3. They've since produced a new version, AutoStakkert 4. It has the same benefits, it does the same thing, but it just does it more gooder. So that's why we're at AutoStakkert 4. So it processes it faster, better, more gooder. So you've got all the controls are on this screen, and all the processing and the video, the actual image, appears on this window. So let's open up the files. There's our 22:07 and 22:08. I record in SCR format, so that's 2024 February 23rd of February at 22:07 and 3/10 of a minute. So let's have a look. Let's open those both up. So if you press the control button, select them both, and then close and process data. So here are all the controls. So we're shooting a surface. You use this if you're shooting the moon or the sun. It's not the planet, which has got black all the way around it. So we're going to put it on surface. Improved tracking I find is quite useful, and then I always use expand. So if you're tracking slightly off, you know, if it wanders around a little bit, it means that the image will take out that whole, you know, it'll expand out as that tracking wanders off. You can put it on crop if your tracking is really good and you're confident, and if it does wander off a bit, it'll just crop to the original frame. So you can leave the quality estimate at automatic, and what it's doing is it's looking at the signal and it's trying to work out how sharp is your image. So you can have a really sharp frame that's full of noise, and therefore that can confuse the algorithm. So I tend to leave it on the normal range, and then the other thing I do is just move the anchor to somewhere that's got nice contrasty stuff. So we've got loads of good shadows and loads of bright craters, and what it's trying to do, it's trying to find something that to line all the images up so they all line up on that common bit in the middle. So I use the normal noise robustness. I leave it at about this midpoint. If you've got a very sharp image, you have very low gain, there's not a lot of noise in your raw frames, then by all means move that up. Conversely, if you've got very noisy images, you know, really been pushing the signal strength, you've really pushed the gain up, then again you can move that down. So I tend to use the normal range. Let's analyze that. Now the other thing I've done as well is I have cut down these video files. They were something like 25 gigabytes originally, so it was so big. So I've compressed them down to just a few hundred frames. Otherwise we'll be here all day processing these. So this is a cut down version. The process is still the same, but these are just cut down video files just to improve the processing time. So as you can see now we have a red square. Let's make that a little bit bigger. We have a red square around the image, so my tracking slightly wandered off. So I find this bit quite useful. So it's ordered the frames, the software's automatically ordered the frames into sharpness order. So the one it's displaying here is the sharpest video frame. Now if we move this slider all the way to down here, you'll see they all wander around as the scene goes through, but the quality gets worse and worse and worse, and the ones down the end are the blurry frames. So that one there you can see is much blurrier, the very last frame, than the sharpest one. So we know it's done the right thing, and therefore, so just remember to check it when you've done your process, when you've done your analysis, just to make sure your settings are right. And if you've got frames appearing in a different order, you've got sharp frames appearing after blurry frames, then you know you've got your order, your quality estimation wrong. So that looks about right to me. That's the sharpest frame, and that's the blurriest frame. And again, you can go back and check your quality slider, just move that around if you think the software is getting the quality, the order wrong. So if you remember when we were playing the video, the seeing was all moving around and the thing was moving around. So what we're going to do is break the image down into squares, and it's then going to look for the sharpest bit in each square, process those, and then recombine them afterwards. So it's pretty hardcore maths, pretty hardcore processing. So I tend to use 120 pixel size simply because otherwise you end up with hundreds if not thousands of squares. Let's have a look. Of course, if you're shooting a small planet where you've got a small disk, you can do more alignment points. Let's have a look. That's having a think. So it's 367 alignment points. So it's breaking that image down to 367 little squares, find the sharpest in each one, and it will then recombine them. Of course, you could go ridiculous and say if we clicked on 32, this will take a while. Yeah, 5,398. So the software is going to be here all day, breaking that all down. It's going to get confused trying to line them all back up again. So that's why I found, in just my experience, 120 seems to work quite well. Nice compromise. Again, have a play around, see what works on your settings, see what you can get away with. Right, the other important thing I do is hit multi-scale, and that means you've got different sized squares. So most of them are 120, but it's also put some smaller ones and some bigger ones, and what that does is it reduces that risk of forming like a mosaic where you get squares appearing on the picture. So by having larger ones, it smooths over that overall grading. So definitely click multi-scale. I do find this graph quite interesting. This is the quality graph, and it shows you how good the seeing was as the seeing came and went. It comes and goes. You get sharp frames and poor frames. And then the blue line is it broken down into quality order, so as it's finished its stacking. So the blue line is as it has finished stacking, so it's now sorted into order. So that's 50%, 25%. You can see there we get some pretty good frames. So you have a choice. You can either stack in numbers of frames, 1,500 or 2,000, or you can stack in percentage, or you can do a combination of the two. So I generally stack in like that, 1,500 or 2,000, but just for a bit of difference, let's have a look on here. You could do say 25% or even 50%, and you can type in whatever numbers you want. I don't know, let's put 500 in here, and we can hit stack. Now this is the point where you have to go away and make a cup of tea, because this can take forever, particularly if you've got a number of video files to process. So when I've finished observing at the end of the night, I've packed the telescope away, rolled the roof back, shut the telescope down. I will then leave this running, so when I come down again in the morning, it's already processed the images, it's stacked them all, the videos up overnight. So it does take a while, particularly if you've got a large number of video files. So I'm going to go make a cup of tea, and I'll see you in a second. So AutoStakkert has finished now, it's finished stacking it, and I have made my cup of tea. And this is from Nicola. Nicola sent me a mug, and as you can see there, it's a picture of the moon, the lunar eclipse. So how appropriate to be having a cup of tea in a moon mug while we are processing pictures of the moon. So thank you very much indeed, Nicola. So let's have a look in here. So I saved all my processing in here, and it was the 23rd of February. So AutoStakkert saves the stacks, AutoStakkert 500 and AutoStakkert 1000. So let's open up the 1000 frame stack. We've opened up the best 1000 video files, and then we see there we've got 27 and 2208. So let's open up 2207. As I think, so that is our raw stack. So as you can see there, that's the best 1000 frames stacked one top of the other, but it hasn't been sharpened, so we've only got a stack. But the good thing is we've got a really good signal to noise ratio, so what we can do now is sharpen that. So let's open up this old program Registax. Registax has been the sort of sharpening default bit of freeware for I don't know, 10, 15, 20 years now. I can't remember now, but it's certainly been around for years, Registax. Now at Registax 6. Unsupported anymore, but it still works. What I would love to do is have one program that just did this all without having to, you know, stack in one program, sharpen another, then go into Photoshop. We sort of move from program to program to program. So let's do a select. And 2207 and 2208 were the best ones. So we'll open up 2207. Back in the day, Registax also you would use Registax to sort and stack your raw video files. AutoStakkert's better now. It has a more robust processing engine, produces it faster and with better results. So people tend to just use the sharpening process in Registax. And so because we've opened up a still frame, it's automatically defaulted to the sharpening page, the wavelets page. So I leave all these settings, beg your pardon. So I leave all these settings at their default. I haven't touched any of these for years now, and I use the use linked wavelets function. So we've got use linked wavelets, and what I'm going to do is just move the first slider all the way to the top. So you can see there, just by sliding that slider along, you've got this incredible sharpening coming out now. We've got features on these mountains, inside the craters, that's all come through. Now you can boost it a little bit more if we go, say, 0.15. Now again, this will vary with you. Use whatever settings you feel works better with you. This is what works with my telescope, with my camera, with the image scale we've got. So you'll have to play around with these settings and find what works best for you. So we've got again, we've boosted a little bit more of the details in here, but you can see it looks like a newspaper image, an old-fashioned newspaper image. You've got these little dots here, and that's called the noise. So we've sharpened the image, we've also sharpened the noise. So what you have to do is then come along to denoise, and move that to 0.2. Denoising. Wish my kids had a denoise button as well, that would be much better. So that's made it a little bit sharper, so let's boost that to maybe a little bit more. Go for 0.3. And again, you can play around with this. You can move the strength of the sliders, you can increase the sharpening, you can increase the denoise, and it's just constant trade-off between how many frames you've captured, how many frames you've stacked, how much you can push to sharpening, how much you therefore denoise, and it seems to be this constant trade-off all the time. And really, it all depends on the seeing, because if you've got really good seeing, you're going to have really good sharp frames. And when I was in Florida for the Winter Star Party, and I then realised what good seeing was when you were looking at, say, Jupiter, you know, looking through, say, the 12-inch or the 8-inch refractor, you know, it's just amazing. You could see details in the eyepiece, you know, details inside the great red spot, and that's just because there simply wasn't any seeing. The image was just still. There was none of this turbulence you can see from me up here, up at 51 degrees north. We've got the jet stream, you've got all the weather coming off the Atlantic. But that's not looking too bad. What we can do as well is move this slider up as well. And I find this one sort of, because it provides the fine sharpening, fine detail sharpening, it does give it a little boost. Move that up a little bit. So boosting slider number 6 has produced yet more details in there, but again, it's boosted the noise. So we'll need to do our usual thing. Let's make that 0.3, a similar number. And again, just go back and forth, just try it, just test it, see what works. So there we go, we've got a reasonably good image. I might just reduce that down again, 0.125. There we go. What I've done now is just clicked on the show full image. That's the whole field of view. So we've just zoomed in at 1:1 scale on the center, and then we'll click the do all button. My laptop fan's just kicked in as it does all the processing. Poor thing's cooking away. Probably should put my cup of tea on top of the laptop though, keep my tea warm. Here it comes. Now look at that. So that is the best 1,000 frames out of the best 5,000. So we've rejected 80%. We've rejected 4,000 of those frames, all the blurry ones. We've only kept the sharp ones. We then stack them one on top of the other. That gives you a really good signal to noise ratio, and you can then go and sharpen that in Registax and bring out all those fine hidden details, and that is simply stunning. So we'll do the same process again on the second frame, and then I'll show you how to mosaic them together. So there we have it. There's our original video. That was 5,000 frames long. We've then turned that into a stack of the best 1,000 frames, and we've then sharpened that in Registax. So that's our sharpened stack. So there we have it. That is our picture. If we jump to the next one, that is the other one. I love that little crater, or quite big crater probably, with all the floor in shadow and then those mountains poking up. And if I remember rightly, the South Pole is somewhere around there, and I think that could even be the crater that marks the South Pole just there. So what we're going to do then is, let's minimize you, let's go into Photoshop, and we're going to go File, Automate, Photo Merge. Now because we're shooting at infinity, because we've got such a small sort of field of view, I just leave this all at auto. Blend images together, browse. So we'll choose 2207 and 2208. Choose them both with the control button. Hit OK. And there we have it. So what we can do then is go Control Shift out. So I've merged that all into one layer then, so we've got that all together. There we go. So we've now got a black sky. I will just also crop that. You can see there where it just hasn't. Let's go there. So that's looking better already. Let's zoom in with Control 1, make it 100%. That's again right. So we're going to go Filter, Noise, Dust and Scratches. It just gets rid of some of the fine noise as well around in the details. So that's all right. I can leave those at the defaults again, and then we'll go Filter, Sharpen, Unsharp Mask. Give it a gentle unsharp mask. So if we zoom in to the image, if I zoom in Control Plus, so we're now at 200%. If we look at some of the craters, you get this effect called, it makes sort of like a ring around the image. So you get this bright mountain, there's a good one. So you got this bright mountain here, and because of the diffraction through the telescope, you get this little sort of silhouette that appears in the shadow. You got a bright crater, dark shadow, and you get this sort of pattern like a, I don't know, ring around the bath. See it? Yeah, you see a little bit along here. So select this chap here, which is called the Burn tool, with this little hand. Put it onto shadows. Let's reduce that down to about 30%. And then using these square brackets button, you can make the circle bigger or smaller. And we just want to get rid, darken out those shadows, get rid of that. It's a bit tedious, particularly if you've got a big image. Just getting rid of those. Be careful you don't introduce any false darkening. You don't want to put stuff over there. So make sure you stay on the bits of the shadows. The false data, there's a good line there. So if we get rid of that. There we go. The other thing I do is I go to the histogram. The image there is only at, you know, sort of half the brightness. So we're going to go Image, Adjustments, Exposure. So you can literally just go Exposure 1 and it should make everything much brighter. There we go. Let's move the histogram along a bit. Just make sure you haven't overexposed anything. That still looks quite a nice natural image. Now what you can have is you then can have your shadows appearing darker. So if we go Control L, get the levels up, and I just nibble that back into there. So we've got the shadows are black. Oh, I need to crop up here as well. Just notice that there. The crop command. If you press tab, you then get to see the whole picture without any of the toolbars. So that is the image. The best 1000 frames left, about 1000 frames on the right. So we've captured that through the telescope. We've then sorted, we've stacked the best 1000, we've sharpened it, we've turned it into a panorama, a photo merge, and then we've sharpened it a little bit more, got rid of some of the little artifacts that's come through the telescope. So there we have it, a picture of the peaks of eternal light on the lunar surface, captured with a telescope in the garden in southern England. So we mentioned earlier about the lunar lander landing at the south pole of the moon. So NASA have put all their spacecraft data imagery onto this website, the Lunar Reconnaissance Orbiter, LRO something. It's called Quickmap, and basically it's an overlay of all the instruments, all the data. It's an absolutely amazing tool. I don't use it anywhere near its potential. If you want to see how to use this in properly, then check out the video I recorded with Barry Fitzgerald. Barry's the editor of the British Astronomical Association's Lunar section, and fantastic guy, and he's forgotten more about the moon than I know. So check out the interview with Barry, and he talks us through how to use this. So what we want to do then is compare our image with what we can see on the moon. So if I go zoom in down here, let's move the moon up and zoom in down here. You see here we have this real problem because we only see it from the Earth at this angle. It's very hard to map the sort of limb of the moon because you get this sort of foreshortening effect. So that's Moretus. And I go back to Photoshop. I might actually spin my map around. Image rotation 180 degrees. So at least our image is the same way round. And then let's go. So that crater I know is Moretus. Beautiful crater, got that sort of strong central peak in, which is that crater there. So let's zoom in a bit more. So that's as captured by NASA in lunar orbit. So it's a little bit sharper than my image. Let's grab some layers. And let's put the nomenclature on. So there's Moretus. But you can see here, down here, it's so hard to make out all these features because it's so foreshortened. So if you remember back at the beginning, we were trying to find a malapart A. So there's Moretus down to short. Ring of 3 craters. So there we go. There's our crater. Sort of ring of 3 craters all together. That's short with a crater inside it, isn't it? Yeah, that's short. So let's get the text tool up. That's Moretus. That's short with a little crater inside it. And that's Newton D, G and A. So that's the sort of Newton group down here. That's Newton. I can spell Newton right. Line of craters and a mountain down there. So that's short A. Is the prominent there, the one with the sort of little teardrop on the end. So let's put an A in there. That's short A. Then we've got malapart B and malapart A. Malapart B. So I reckon that ruined crater there, just next to that sort of mountain range. Malapart B, malapart A. So short. So I reckon the landing site is about there. That is the landing site of a space probe to the moon, to the south pole of the moon, that we captured with a telescope in the garden from southern England. So my thanks to my one patron, Rushpal. Thank you for your continued support. If you'd like to see more videos like this, then do consider becoming a Patreon. It means we'll have more resources to put videos together and share the beauty of the night sky with the community.